Okay. So the studies that we do in us, so let's look at humans. I apologize, my nose is running like a sieve today. So when it comes to research in humans here, we look at epidemiological studies, epidemiology, okay? This looks at what is happening within a population. The rate of the occurrence, the distribution of it, how many individuals are affected, and the causes of various different health issues within a population. And we can be very specific with this population. Boys age 10 to 15, girls age 8 to 12, males 30 to 39, females 40 to 49. So we can be very specific with our population here. That's the great thing about these studies. And we have plenty of research out there, and that's kind of what we look at here in class. An epidemiologist uses data. This data can be from surveys. These surveys are done to collect various different information, data points. And we see that with this fantastic little, lovely little child over here. We have a physical exam. We are testing height and weight in these little babies. We also test head circumference. So we measure how long they are, how much they weigh, how big their head is, and that is a physical examination. Then we ask mom how the kid's doing. How many times a day does he feed or does she feed? This is a boy, so he. How many times a day are they breastfeeding? How long are they breastfeeding for? How many bowel movements? All of those surveys, that allows us to collect information. Okay, if the baby eats this much for this amount of time, then they have this positive health outcome, or they're not getting enough consumption of breast milk or food even. Okay, so they have these negative health outcomes. How do I know that? Well, babies who consume more breast milk have more fat to them, more body weight, fantastic. They have a bigger head. Bigger head means brain grows. Growth of the brain equates to better outcomes with learning and understanding. So there's a lot of things that we can figure out and determine if there is some kind of correlation or if there is a cause and effect relationship between consumption of foods or certain foods and adverse health outcomes, negative health outcomes. Being able to explain the differences between the various different types of epidemiological studies, that always makes a potential good essay question on the exam. We have experimental studies and we have observational studies, okay? Most nutrition research is observational, okay? That's what the vast majority of it is. There is some experimental, but I mean, it's got to be, some of them we can't do a lot of experimental research in certain situations. When we look at experimental, we're looking at, maybe administering drugs or, vaccines or seeing if a medical treatment is necessary. That's going to be more experimental. So for nutrition, a lot of what we do, for studies is going to be observational in that regard. Experimental studies, what are they? This is the definition. Introduce an intervention, and study the effects. Okay. Usually we get a random assignment of treatment groups and control groups, which is fantastic. Okay. Again, having those control groups are necessary to truly see if the study was effective. And the great thing about this, and I have it in bold right here, we can draw a cause and effect. This specific thing caused this specific outcome. That's the great thing about experimental studies. And observational, not necessarily getting that. Okay, we're not necessarily getting that cause and effect, that direct connecting of the two dots. Okay. Again, most of our studies in nutrition are of this ilk, this observational studies. Okay. And I give a number of different kind of things there. You know, we can observe risk factors. We can observe diagnostic tests and what that means. We can look at treatment. We can look at other interventions. Other interventions, just throw a dart against the wall. When it comes to those, there are a number of them. These generally do not necessarily prove a cause and effect relationship. Consumption of this specific type of food causes this specific negative health outcome. Okay. These just show a correlation. Even more CYA, potential correlation. That's what these type of studies show. Right? So that's why nutrition research is so ongoing. It changes all the time because it's never a one-for-one type of thing. This specifically causes this. Okay, there's a potential correlation, but there's a number of factors that go into that that can influence you to have that negative health outcome or not have that negative health outcome. When it comes to observational studies, we have two types, case control studies and a cohort. A cohort is just a group, okay? A cohort is just a group. That's just a fancy word for a group. You guys are a cohort. The 35 people or whatever's in this class, you guys are a cohort, okay? You're a group of individuals taking this class this semester. So let's look at these. Case control studies. Here you can see we can identify a specific health problem, a specific case control. Okay. And I give an example there, heart disease. Okay, that's going to be the health problem we're looking at. All right. And we look at a group of individuals that have that same problem. These are fantastic. Okay. These types of studies are very quick, okay, which is easy, doesn't cost a lot of money. They have a very small number, which is what makes it quick to begin with, okay, which does make it easy to do these type of studies. But that's also a disadvantage. If we're looking at heart disease here, okay, and I'm looking at 10 individuals, can I equate 10 individuals over 10 million people in a population? No, I can't do that, right? So that's a huge disadvantage. You want as many data points as possible when it comes to these type of studies to equate this to the populace. Okay. Again, proves a correlation, does not demonstrate causation, a cause and effect type of thing. Okay. If we have too few of individuals, again, it could just be random chance. Why would I want to do this type of study? Well, I mean, you can investigate rare diseases. You can study some potential outcomes of various different health conditions. That allows you to maybe set up a much more huger, grander kind of scientific research on that health outcome. They're great for investigating outbreaks. So these case control studies do have a purpose, but when you're trying to equate what's happening to 5 people instead of what's happening to the state of Missouri, you can't do that. For cohort studies, these generally look at, as you can kind of see right there, I have it all highlighted and underlined for you. Okay, we look at a specific group of people, okay, born during a specific amount of time. And we look at those who have that health condition, who have been exposed, who are in that age group, let's just say 20 to 30. And then we look at individuals who have not been exposed, age 20 to 30. Okay. And we try to compare those different groups, cohorts, okay, and see what was done during that time frame for these individuals and what happened for these individuals during that same time frame, or what was different. Okay. And these type of studies have a huge amount of numbers. So that's what's good. So, pluses and minuses, what's good, what's bad about these two? What's the definition of it? What are you looking for? Those are the type of things that if I was to ask you to compare and contrast observational studies, that would be the stuff that you would probably put down, hopefully. Large number of individuals. The bad thing, it's always money. These cost a lot. These generally involve a huge follow-up, especially if you're trying to kind of see what happens to an individual 20, 30 years down the road when they're exposed. Let's just say I have a group of children whose dad smoked, a pack of cigarettes a day. That pack of cigarettes was generally in front of them. What does that do for their overall lung health? Now I want to compare those individuals, those kids born in 1990 to parents, one of which smoked a pack of cigarettes in front of them. And I want to find another group of individuals who were also born in 1990, who were not exposed to nicotine, to smoke and whatnot, secondhand smoke. And I want to see what that does. I want to see what that does for their lung development over the course of the next 30 years. Well, that's a huge follow-up, and that takes time. Got to follow up, got to track them down, you got to administer the test and whatnot to test for lung function. So obviously these can be a very long follow-up, be very costly. So these type of studies, these you don't hear about until, way down the road. When it comes to cohort studies, they can be retro, or they can be prospective. Okay. And I have certain things bolded, underlined, highlighted here for you. Those are probably some of the key distractors that you would see, if you were to try to pick these out of a lineup in a multiple choice test or a matching type of question. Or if you were having to write these down, these would be some of the things. Retrospective, we collect information. We look at past exposures and identify current health outcomes. Okay, these are conceived after the fact. Okay, after they've already developed some of these things. I think there's a picture here. Yeah, right here. After they already have some kind of negative health outcome, we look back and we see what these individuals did. Did this individual eat a lot of nasty foods, a lot of fatty foods? What does that do for their coronary arteries later on in life? Okay, so that's a retrospective study. Prospective, well, we kind of follow it in the moment. They're followed over a period of time to see what diseases actually develop. Studies are conceived before the individual has been afflicted with the condition of interest. All right. For a prospective cohort study, we gather a bunch of Black males age 20 to 25, or white males age 20 to 25, females, whatever the case may be. So we have a specific cohort, a specific group of individuals, okay, relatively the same age, okay, males or females, we divide it up and we follow them over the course of their lifetime. And we try to see what they do daily, weekly, monthly, and see what that does for the development of certain conditions of interest. Okay, that's the difference between epidemiological studies, is the overall arching theme here. Observational is for nutrition. Cohort is just one of those, retrospective and prospective. Observational studies, case control, have a group of individuals and have a group of controls. Have the issue, don't have the issue. Why? I keep saying this word, correlations. Correlation is just a relationship. Okay. What are the relationships between variables? Do these relationships increase the incidence of occurrence? Do they decrease the incidence of occurrence? Does one variable increase and the other one decreases? Does the correlation and the variable go hand in hand? And that's what the difference is between direct and indirect. I don't have you generally write these down and explain them on the exam. I never have anyway. I generally ask it as a multiple choice type question on the exam. Okay, but correlations can be direct or indirect, positive, negative. You can look at it both different ways. Okay, positive correlations, they may increase or decrease together. And indirect, they kind of go in opposite directions. Limitations of these studies, again, like I said, experimental is really the only one where we can go cause and effect. Direct cause, direct effect, all right? When it comes to these observational studies, I mean, you're looking at that person in their 20s and what happens to them in their 70s. They've lived a lot of life. You haven't controlled that. Did they do drugs? Did they not do drugs? Did they take medications? Did they not take medications? What did they drink? What did they eat? Where did they live? Did they travel anywhere? What's their stress level? What's their sleep patterns? There's a lot of different things. There are a lot of different variables that you have to account for. So we cannot establish causation with these epidemiological studies. Okay. I mean, hell, if you're relying on a survey, do you guys remember what you ate last week? No, I don't remember what I had this weekend, let alone last week. So there's going to be just some inaccuracies, okay? When you're writing down, when you think about, do you eat well? And be like, yeah, I don't eat too bad. I eat green beans with dinner. But do you eat a serving of green beans? Do you eat 2 servings of green beans? You're like, well, I don't eat much meat. Okay, what the hell is much? When you start weighing out what you're eating, you're going to probably look at it and be like, holy smokes, I'm eating 10 ounces of beef with every meal. That's probably not going to be good long term. And it's probably not going to be good long term. Okay, but there is just a healthy user bias. You always go a little lower on the bad stuff. You always go a little higher on the good stuff. When you are eating, measuring what you're eating, estimating best guess what you're eating, that's going to allow you to really get an idea of how many calories you're consuming and be a little bit more accurate so you can make some good changes in your life.